So the last topic we're going to cover in section 3.4 is combinations. And a combination is when you have n total objects and you're choosing them r at a time. And since you're just choosing a group of items, that indicates that order is not important. And that's the main difference between a permutation and a combination. A permutation is an arrangement, so order is important, like first place, second place, third place. Whereas with a combination, you're just choosing 3 things, and it doesn't matter which one comes first or second or so on. Now, just like permutations, there is a formula that you can calculate combinations with. The symbol for combinations is NCR, and that stands for n items chosen r at a time. And here is your formula. So if you look at example 4 underneath here, I worked out number 4 using the formula. It's 14C5, so it'd be 14 factorial over 14 minus 5 factorial, which is 9 factorial, times 5 factorial. All right? And you're going to get an answer of 2002. Now I wanted to remind you on the graphing calculator, the factorial is located, if you hit the math button and then go over to the probability menu, it's option number 4. Okay? Now you can type this in all at once, but see how I've put parentheses around the denominator? You have to do that to get the correct answer, so it knows to divide by everything that's in the denominator. However, if you look on the graphing calculator under that same menu, combinations is choice 3. You can just use the calculator to calculate these as well. The formula is programmed in. For example, problem number 1, 8C5, I would type in 8, go to my probability menu and choose the combinations option, then type in 3, and when I hit equal, I would get an answer of 56. A more practical type of problem, if you look at the next example, says a state's Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the building companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? So we're not really interested in who's the lowest price, who's the highest price. It just says we're just going to choose 4. And so this would be a combination, 16C4, and either using the formula or the calculator, you will find that there's 1,820 different combinations of 4 companies that the State Department could choose from. Combinations can also be really helpful when you're trying to calculate large probabilities. Okay? If you look at the next example, it says a word contains 1 M, 4 I's, 4 S's, and 2 P's. If the letters are randomly arranged in order, what is the probability that the arrangement spells the word Mississippi? Well, the first thing we need to know, since it is probability, is how many ways can you spell Mississippi, and then also how many total different arrangements can there be. And the clue word there is arrangement, lets you know this is a permutation, meaning order is important. However, this will be a permutation where we have repeating letters. So we're going to have to do the formula that we used at the end of class yesterday, which is you take the total number of items factorial in the numerator, so 11 factorial, and then for each item that repeats, you have to divide by that factorial. All right, and again, if you want to do this all at once, you need to put the denominator in parentheses. So using the calculator, I'm going to type in 11 factorial. Let's see if I can get that where you can see it. There we go. Divided by, and then in parentheses, 4 factorial times 4 factorial times 2 factorial. Close the parentheses, and you will get that there are 34,650 different arrangements using those letters. Now, as far as calculating the probability of actually getting the word Mississippi, you have to ask yourself, how many different ways can you spell the word Mississippi? Well, there's only one way to spell it. There's only one correct arrangement, and then it's out of the total number of arrangements, which is what we used our formula for.